Hi, my name is Leandro Facchinetti, and in this video I'm going to do a code review of the project I showed you in my previous video. And in case you have not watched that one, my project is called GitHub SQLite. It is a library to let you use SQLite in Node.js using tagged template literals. So it looks like this. You can use a tagged template literal and interpolate values right in the middle of your query. And it also keeps track of all prepared statements so that you don't have to necessarily keep those objects around in your application. You can just write SQL like this and it will reuse the prepared statements. It also has some a few auxiliary functions that are just mostly for convenience. Things like execute so that you can pass a tagged template literal, but there's also the execute transaction. It's just a small function. In fact, I think I showed the implementation of these auxiliary functions in the previous video. It's so simple. But in this video, we are going to go in depth into the implementation of the library itself. It's an extension of Better SQLite 3, which is doing most of the heavy lifting. So there is this other library that already has a connection to SQLite databases. It handles transactions. It does everything that you need it to do, but then there is my library that just is a thin layer on top of it with some sugar, some niceties, a better interface, a better API, at least to my tastes. So we're gonna go over the implementation of all these methods. It's not a long implementation, around 100 lines of code. I'll also briefly discuss how I am testing this library, which is not entirely surprising. I'm just creating a database, then running some SQL to test that. And then we are going to go over the configuration for TypeScript for the project itself, and then for the GitHub Actions that test and publish this package. So the package is written in TypeScript, and this is important for two reasons. First, because of the types. I like having the types here. It helps me write better code. It also exports the types so you don't have to import add types / something package to use this library. It just comes with the types. But mainly the reason why I like using TypeScript in this context is because of the generics. This allows me to write code that represents the intent of what I'm saying much better. So here in my tests, I can, for instance, show you some get, and then I can say what I expect the output of the query to be. In this case, because there is a user table with a single column of name, I expect the output of selecting star from users to be a name of type string. And then that's exactly what comes back. It also comes back with an ID, which I did not declare here. But the point here is I can do things like after I do this query, I can get the name out of that field, and TypeScript will get me the right auto-completion, also the right types for everything I write, so I will not make simple mistakes. So yeah, the thing is written in TypeScript, and let's first on a high level discuss how this management of these statements work. So what happens here is I have this database class that extends from the database class in Better SQLite 3, and then I keep a map of statements from the source, which is literally the text of the query, to a Better SQLite 3 statement. So in case you don't know how this statement thing works, I briefly discussed it in the previous video, but there is also some API documentation here in the Better SQLite 3 package that explains how this works. So you have a database class, which in our case is this one, and then you have to call prepare with a prepared statement with the text of the prepared statement, so the SQL itself. And what this is doing is just mapping inputs to outputs. So it's mapping this query, for instance, into an object like this statement object. can think of this as something called memoization, in case you know what that is. Or you can just think of it as a map from the text of the query to a statement, which is an object that we can use to actually execute a query in the database. Because if you have a statement object, then you can do things like run and get and all that actually go to the database and do stuff. So that's the heart of the state management. It's just a map of texts or SQL, raw SQL to statements. And I have no policy for taking things out of this map. You can think of this map as a cache. That's another way of thinking about it. Instead of creating statements every time you wanted to run a query, you just go to the cache of statements and get it from the cache. There is no notion of evicting stuff from the cache. So if you are using this library, my library, with an application that is creating new queries, programmatically creating new queries, and may create arbitrarily many new queries, then you would be in trouble because you would be creating arbitrarily many of these statement objects. I don't think that that's the case for most applications, however. In most applications, you just have a certain number of queries in your application. In your source code, you will have all over the code base just a limited number of these queries. And they will interpolate different values. So in this case, we do have an interpolation here, and the interpolation will have different values. Sometimes the name will be Leandro Facchinetti, sometimes it will not be Leandro Facchinetti. But the number of queries, the number of text queries in your code base is limited. So this approach holds water. And I think that most applications would completely work in this model. And it's still possible. This is just a public field in the database class, or in the database object. So you could just introspect into the statements and delete statements and implement your own cache policy or cache eviction policy. But it's an advanced use case. I don't think that most people would need this for most applications. So that's the statements object. It's just a cache or a map or a memoization of source of SQL to statements. No cache eviction policy. So what's going to happen is that we are going to create one of these statements here. So I have here this get statement that is an auxiliary function. It's public because you may need to do some advanced things with statements. And then if you need to do that, then you can get a statement just by the source. But this is not used directly in most applications, I don't think. But it is used in the implementations of all the main methods of the database, the main methods that you would use to interact with the database. So the way this works is it gets as arguments a query object, and we'll look at how the query object is formed later in the video, but you can think of the query object as something that is produced by the tagged template literal. So if you have something that looks like this, by itself, this is a tagged template literal that will create that. Effectively, this is just a way to call a function in JavaScript, okay? It's just a fancy way of writing a function call. Another way of writing it would be like this. So you would pass as arguments the parts that constitute your query, like this, and then there is some interpolation of values. So that goes here, and then there is the rest of the query, which in this case is just closing this parens. So that's another way of writing this. It doesn't exactly work, but you can think of a tagged template literal as a function call that works this way with this signature. So it's just a function call. It may return anything, and it returns one of these query objects, as you can see. And the query object is pretty simple. It just has two fields. You can see the interface for a query object over here. It's just two fields, and one of these fields is the source. That's the text, the literal SQL query as a string. So we receive as argument here in the run method one of these guys. Same for query, for get, for all, iterate, execute. We are just receiving these query objects that are created with the tags template literal. We'll look at this part of the implementation in a bit. But now that we have this query object, we can call the get statement method with the source part of the query. So as I showed you, the query has the source, which is the literal string with the source of the SQL. And then you are receiving this as argument, so you call get statement with that source. So this is just literally the text of the string, so the text of the SQL. So in this case, for instance, this will be transformed into a string that looks like this. So anytime you have an interpolation, you actually output a question mark in the query. So this is literally the text of the prepared statement that we need to create. And the get statement method will do a lookup on the statement's cache. If it's a hit, it just retrieves the prepared statement that is already there. If it's a miss, it will create the prepared statement, put it in the map, and return it. So let's look at the get statement implementation. So it receives as argument one of those literal texts. So the source is something that looks like this. And this has been produced by the other method, actually the function, the tag template literal we'll look at in a moment. So this is source. And then there are some extra options to configure the statement itself. We're going to look at the options in a moment. So first I look into the statements map and I try to get it using the source. And if it's a miss, then the statement will be undefined. In this case, I call the prepare method that is actually the prepare method from Better SQLite because we are inheriting that method from the database that that Better SQLite 3 gives us, the database class that is. So this is going to call that method that is in our own object because we are inheriting from a Better SQLite 3 database. So we can just call prepare. Prepare will return that statement, so now we have assigned to that statement, and at this point we are guaranteed, so where the cursor is, we are guaranteed that the statement is defined, either because it was in the cache or because it was instantiated right here. Then I put that thing in the map so that the next time we call the get statement method, it will be in the map. And then I check the configuration, the options. So these options are a subtle thing about Better SQLite 3, and it has to do with unsigned integers. It's an advanced feature in Better SQLite 3, and I can briefly describe what's going on. So if you have, so here I am using TS Node so that I can run TypeScript directly in the console. So here I'll have a database and SQL from source because I am in the in this context I am in the implementation of the Better SQLite 3 package itself, but that failed. I wonder if it is because I am missing the TS. Oh, silly me! I'm missing the / because it is a local thing. So okay, now I have a database. I can create a database. And this one will live in memory. It will not be backed by a file. And then I'll create a table. So I'll run execute SQL create table users in which the ID is an integer primary key auto increment, and then just for good measure I'll also have a name. And now I can do database run insert into users name values, and at this point I can interpolate something. I will interpolate my name. Finally, we can do get of select ID from users. And you can see that this returns a number. Okay, so now we can finally get to the point of the options that I can pass to all of these methods to get all. So all of these, get and all and iteration, they all receive this extra options thing that specify if you want to use safe integers or not. So now we can finally discuss what the safe integers are. So you can see now it's returning this one with the letter N. In case you don't know about this, it is something called a big int. That's the difference between just the number 1 and 1n. It's a big int. A big int is an integer that has arbitrary size. It doesn't have a limit on the maximum integer that you can represent using this. And the thing is, in SQLite, it's possible to have integers that are bigger than the maximum integer you can represent in plain numbers in JavaScript. And this has to do with the representation of numbers in JavaScript, which is floating point numbers. They have a limit on the maximum integer you can represent. After that integer, it wraps around and becomes a negative number. In most cases, this is not an issue at all. But very rarely, you will have something in the database. So for instance, this ID in the database will be so large that it cannot be represented in JavaScript. So if you try to retrieve it from the database, you end up with garbage. What this save integers option is doing is letting you specify if you want to enable save integers or not. You can do that on a query by query basis. So this is just for this query. If I do some other query, it will not return with the safe integers. I can show you, for instance, but if I, instead of just selecting the ID, I select the ID and the name as well. This is a different query. It returns an integer. So this is a way to do for each query. And there is also a way that I did not implement. It comes with better SQLite 3. And then you can set the safe integers for all the database connection. So I don't actually remember the name of the method that you need to call, but it's here in the docs under integer big int. So you can say default safe integers. And now if I do the query again, maybe a new query, I guess I have to do a new query. From users where 1 equals 1. Yeah, so this was already set because I have created this before I called the default safe integers. It was already in that cache. This one is not in the cache because it's a new query, and the 1 equals 1 is inconsequential because it's always true, but it returns the safe integers, and this will be true for all queries from here on. I suppose you would probably call this default save integers before you even run any query in the database, because you are doing that in the setup. When you created the database connection, you already set the default save integers, if that's something you care about. In most cases, you wouldn't care about this. It's not an issue at all. Unless you have really, really big integers in the database, it will not be an issue. In any case, I do give you that option. So there is this extra argument. It's always optional. Most people will never pass anything to this, but if you do, then it will enable the safe integers in a specific statement. I don't have to do any extra work to support the default save integers option because I just inherit this method from better SQLite 3. So now you know, if you are passing this save integers option, then I will set the save integers to whatever you set, because you can also do the reverse. Now I am in a situation where the default is to have big integers, but I can say save integers false, and then I'm opting out. So what I'm doing here is I'm checking, did you pass an option at all? Because if you did not pass an option, I don't want to change anything about the default from the database, either the default safe integers or the default which is not safe integers. If you did not pass me an argument, I am not going to do any work. But if you passed me an argument, then I will call this statement safe integers method, which comes from better SQLite 3. So I guess it's here. Yeah. So in this statement, you can call safe integers. And I only call this if you pass me an argument. Then I return a statement. So get statement will, in summary, look up the cache. If it's a miss, it's going to create a statement. It's going to populate the cache. It's going to set the safe integers property of this particular statement if necessary. If you passed me an option, then I will do that. And then returns a statement. This getStatement method is called in, as I said before, all the main methods that actually do stuff to the database. So they all boil down to get a statement based on the source and forward the options. So all of these methods accept the options, but they are just to pass the options along to getStatement. So all of them look the same. And then I will actually call, remember this is going to return a statement. So I can actually call the method in the statement. In Better SQLite 3's documentation, there are all these methods in statement objects. Run, get, iterate, and all. So I just call those methods. And then when you're calling those methods, you have to pass as arguments the binding things. So the interpolations in the queries. Or coming back to our example where we had a query that looked like this. So your query object, in this case, I'll give you an example with the get method, why not? So your query here is equal to something whose source looks like this, and then the parameters look like this. And that's because that was your original query. So your original query that reads like this, the SQL text template literal function will produce an object that looks like this. And that's our query. So we have the parameters, which are just their interpolated values. They just appear here. And then I call the Better SQLite 3 method with the parameters. And I suppose that the methods accept bind parameters. Yeah, they accept a list. So yeah, they accept a list or they accept just the value. And in this case, I'm just passing a list. So that's how this class works. It extends Better SQLite 3. It has this cache of statements. It looks up on the cache or populates the cache if necessary, and then calls the method in the statement that is Better SQLite 3 statement. There are a few things I want to mention about the generics. So the way this works is in TypeScript, you can define a generic type. So T is any type you are giving. So when you call, for instance, in this case, get, you are giving me the type, and I call this type T. So it's a type parameter. It is similar to these guys. They are value parameters. This is a type parameter. You are giving me the type, and I'm saying this function is returning either that type or undefined, because the query may not result in anything. There may not be that line, that row in the database. And it's a similar thing with all the other methods. You are passing me a type when you call .all. You're passing me a type, and I am saying, okay, the type is now a type parameter, and all is going to return a list of that type, and so on. In the case of iterate, it returns an iterable iterator of that type. And this is the code I had to write to allow you to do things like this using generics and specifying the types that are returned by your query. Now let's look at the rest of the methods here that execute transactions, that execute arbitrary queries in this case, and that execute transactions. And then we'll go on to discuss how the text template literal itself works. So let's talk about execute. This one is a simple wrapper around exec, which is a Better SQLite 3 method that you can call on the database. You don't have to create a prepared statement for this. You can just pass the text of the query to the database and it will run that query. And you are not allowed to have any placeholders. You're not allowed to have any of those question marks I showed you in the queries before. You're not allowed to do any binding of parameters. These are just raw SQL queries that you can execute on the database. And the reason why I had to implement execute is twofold. First, execute is a full word, while exec is an abbreviation. I prefer it this way. But also, and I guess this is probably the most important reason, it supports a query object. As I said, you are not allowed to do any kind of interpolation. So when calling execute, I think there is an example of this somewhere. Yes, this is the example. So when calling execute, you are not allowed to do any of these interpolations. In fact, as you can see, this throws an error. So what I'm doing here is just create this wrapper so that you can call execute with something that looks like a text template literal, which is beneficial because you get syntax highlighting, you are seeing what kind of language you're working with. So there are all these advantages of using a text template literal, even if you are not allowed to do interpolation. So what you can do in most cases is just call the text template literal with some raw query, and that is going to produce one of those objects we looked at before. So it's going to produce one of these objects with a source and a parameters fields. And then execute is able to work with an object that looks like that. So execute is a thin wrapper around exec that is a full word. I like that name better, but more importantly, it works with the query objects. So you are able to pass a text template literal into execute. Now, what I do here in this method is first I check if you did any interpolations, because if you did, then there will be parameters in the query, and in that case, I throw an error. Otherwise, I just run execute. And execute in Better SQLite 3 or exec in Better SQLite 3 returns the database itself. And that's mostly for chaining, I suppose, because you can do things like database exec of something like create table blah 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 dot something like as exec maybe. I don't know. You can do things like that. You can chain calls like that. Or you can do like prepare to call, to produce a prepared statement, whatever. So I just follow this convention and I return whatever exec is returning, which in this case is this. So I say this as the return type. And this is a super cute type because remember that we are extending Better SQLite 3. So this keyword is saying that I'm not returning one of the Better SQLite 3 database objects. I am returning myself. So I'm returning the object that I created with this extension. So it's the case that exec would return a Better SQLite 3 object, but because I am calling this in my object, it's returning one of the children, not one of the parents. Finally, let's look at the methods that implement transactions. So in my previous video, I showed why you would want to have these methods, but I can briefly recap. So the idea here is that if you are doing transactions in Better SQLite 3, then you have to create a transaction object. It does not execute immediately, and then you have to call that. So I guess the object here is a function. But I thought it would be nice if you could just pass a function that would be called with a transaction. So it is just calling transaction from Better SQLite 3 and then immediately calling the function. So that's what's happening here. For instance, execute transaction is calling transaction with an argument that I'm just forwarding and then immediately calling it. So instead of having this transaction object or variable here, I am in this place right here, just immediately calling that function and returning whatever it returns. Again, I'm using the generics here because a transaction may return a value when you actually call it. So in this case in particular, right here, it could return a value. And so do I. I return whatever that would have returned. And then I am using the generic here as the return type of the function you passed me, because that's how the transaction function works in better SQLite 3. As you can see, it is receiving a function that returns a type T right here, and itself, it returns a type T. So that's what I do as well. I'm just forwarding the arguments and forwarding the outputs. In a way, you can think of this as a proxy around execute transaction that presents a better proxy around transaction that implements a better interface. You can call this a facade, if you will, I think. Don't quote me on this. Okay, so the same is true of execute transaction immediate and exclusive. They are just different ways of writing this execute transaction, and they work differently. They have they lock the database in a different way. When you're doing transactions, if there are multiple transactions running, you need to lock the database so that they have a consistent view of the world. And there are different ways to lock. Optimistically thinking that most times the lock will not be necessary, so you only lock when absolutely necessary, when multiple things are trying to read or write to the same at the same time. Or you can do it pessimistically or immediately, which is to lock the database as soon as you start the transaction. And so I just give you these different flavors of calling transactions, which under the hood are just forwarding to the appropriate methods from better SQLite 3. And that is it. That's it, the entirety of the database class. So now we can move on to the text template literal. As I said, it is a function. It receives as argument an array. So I suppose it's nice if we can go back to that example that we had before. So I'm going to recreate it. So you can think of a call to a text template literal that reads like this as a call to a function that looks like this. All the parts that compose the text template literal, so all the parts that are strings that are not interpolation, so all these parts become a list or an array with strings. And all the interpolations become extra arguments. So here I only have one, but I could have something like ID and then an interpolation of like so. And then of course here I would have ID, and then right in here I would have something like this. And then I would also have the extra argument like this. Okay, so if you are using a text template literal under the hood, what JavaScript is doing is transforming that into a function call that looks like this, with an array of the parts of the text template literal that are a string, and then all the values that are interpolated as extra arguments. So one is an array, and another one is a list of arguments, a bunch of arguments. And then there is this template thing here that is not a type. The type here is not string list. It's not an array of strings. It's this special type template strings array. And the reason why this is not just a regular array is because you can, if you want, access the literal thing that the person wrote. So if you have something like a \n in here, this \n is literally available to you, because usually the \n would translate into a new line, right? So at this point it would be a new line over here, so something like this. But if you want to, you can access literally the \n. That's useful if your language is not SQL, but a language in which backslashes have special meaning, like LaTeX. Or something like that. So you would want to access literally the \begin document, because \b is not the intent here. And you can do that with text template literals if you access template raw. So that's the thing that distinguishes a literal just string list from this guy. And that's the one that we have to declare here. We don't actually use template raw in our implementation, but I wanted to let you know the difference between just a list of strings and a templates strings array. So then there are all the substitutions, and this is a list of substitutions. There may be multiple. Now we are going to go over both of these, so both the template and the substitutions. We're going to go over them in sync. So we're going to go over them in a way that gets this element along with this interpolation, later gets this element along with this interpolation, and so on. So we're going to go and traverse them in sync. That's what's happening here. I have this index that is just a number between 0 and the length of the list. So in this case, for instance, the list has length 1, 2, 3. So the template index will go from 0 to 1 actually, because it's the length minus 1. So we are just going to traverse and get this element and this one. Later we'll get this one and this one, but we'll never get to this. And that's because there is no corresponding interpolation here. This last part will be dealt with right here in this line. So we are traversing that, but what are we doing in the traversal? Well, we are going to accumulate the parts of the source. So we are going to accumulate this and that and that and some other parts that are necessary as well, because in the end, the source has to look like. So our ultimate goal in this case is to have the place where the interpolations happen as question marks, because that's a placeholder for SQLite and for better SQLite. So those are the placeholders of the values that need to be plugged into the query when we actually run the prepared statement. So there are the source parts. These are a final goal, but the source parts are going to be things like this. So the source parts will be just a list of all the parts. And then we, at the end, will join all the source parts to produce a string. So this is source parts. And this will be our eventually will be the source. And this is our template. And these are the substitutions. Of course, this syntax doesn't exist, okay? I'm making up this syntax just to communicate the idea. So what we are doing here in the traversal is we are accumulating the source parts and the parameters. We're going to traverse both of these, template and substitutions, and we'll be accumulating the result of our work in the source part and parameters. And the parameters I did not write, so I'll write them right here. The parameters will be a list of these elements, like so. That's the intent, that's what we want to produce. That's what we do, that's what we have produced here at the end. An object that has a source and parameters. The source parts are interesting. Why am I doing this as a list and then joining everything together? I could just do this with a string and then add to the string. So instead of having source parts, I could have something like const source, which is a string, or actually not const, but let source. And then here, anytime I wanted to do something to the source parts or append stuff to the source parts, I could say source plus equals something like this. That's what I want to add to my source. The reason why I'm doing this with a list is because I think that this is more performant, but I am sure that this makes more sense to me. I'm thinking of the source parts as a buffer as I'm building the query. And I'm not producing new strings. So remember that in JavaScript, strings are immutable. That's why I had to say let source, and then I had to change the source variable to point to something else. That's because strings in JavaScript are immutable. And I don't want to create many of these immutable strings. I prefer to just use the ones that already exist to build this list. So you can see that these two are exactly the same. I'm reusing a string instead of creating a new string that I would have to create. I would have to create a string that would read like this. And then I would have to create a string that read like that. And then I would have to create another string like this. And then another one like this. Instead, what I'm doing is just accumulating everything in a list, reusing the same strings that already exist, and then I'm joining everything together. Maybe the addition of strings would be optimized away by the JavaScript execution engine, but in any case, I think it's not only probably faster, I haven't benchmarked, but it's definitely, it makes more sense to have this buffer as a list like this that you join at the end. Okay, so then what we are doing here in the loop, we are getting the parts of the template and the parameters. So at this point, the template part will be, for instance, this in the first iteration of this loop, and the substitution will be that. And then I'm checking, okay, this is a feature that I have not mentioned before, but if you want, you can interpolate literal SQL. So in some cases, it's beneficial to have a programmatic way of creating the query. So if you have a query that reads like select star from users where, or maybe that's exactly the case. So maybe you want to say something like, maybe this is a web server and then there is a request, query, name. If this is undefined, then I'm not doing anything. But if it's defined, then I want to interpolate where name equals rec query name. Like that. So what this is going to do here is produce a query that if you did not pass any parameters in your request, then it will be like this. Otherwise, it will be like this. And what's happening here is that I'm eventually producing a query that reads like that. So you are able to programmatically generate different kinds of queries, and this is usually not an issue because the amount of queries that you can generate is fixed. In this case, you can only produce these two queries. It will either be this one or this one. So only two kinds of queries. So there is no problem with the cache that we looked at before. There is no problem of maybe blowing up this cache with too many entries. No, the number of queries you can produce is still fixed. That's okay. But you're producing those queries programmatically depending on the kind of request that you got. So that's something you can do. If you do it like this, then you are trying to interpolate a value. Eventually, this would generate a query like this, where this would expect a value, but that's not your intent. Your intent is to produce something that looks like this. So I created this, I stole this idea from another package, but I created this notation. So the double $sign is not something that typed template literals interpret. What will end up showing in the source parts is something that reads like this. It's a string that ends with a $sign. And there is no special meaning to this. It's just that I interpret in my tagged template literal function, I interpret this in a special way. So it kind of looks like syntax, but it's not syntax. It's just a clever trick that I stole from somewhere else. I did not come up with the trick. So the way this works is I look at the source part. So does my source part end with a $sign? Because if it does, then I have to do something special. I'm not going to consider that the next thing that comes up. So for instance, this would not be the number 30. In this case, because we are doing this special interpolation, this is SQL itself. So this is another one of those query objects. So this is not the number 30 in this case. This is something that has a source field with something like where and so on, and parameters. May have parameters. In this case, it does have parameters. I think that the parameter I passed is rec query name. So it will look something like this. Of course, it will look like the value that you passed for name. So maybe this. So the parameter here is not a value that I want to interpolate. A parameter is a SQL query that I want to splice into literally into the text of the SQL search that I'm producing. So what's happening here is I'm checking, does the template part end with a $sign? If it does, I'll have to do the magic trick. The magic trick is, well, first of all, I have to check, did you pass me something that looks like a query? So something that has these fields. Did you pass me something that looks like a query that has these fields? So if you did not pass me one of those, then I'm going to throw an error because you did not interpolate with a query. So that would happen if you did something like this. You did an interpolation like this, a special one with the double $sign, but then you did not pass me a query. You passed me maybe something like this, an empty string. This is not a tagged template literal. It will not produce, maybe even that, which is even worse. So that is a string. It's not a tagged template literal. It will not produce one of these objects, which means that I cannot do a raw interpolation. So what I'm doing here is checking the shape of a query object. If the type of the parameter source is not a string, or if the parameters are not a list, so I suppose that this should have been a list. So if the parameters are not a list, then I will throw an error because you are trying to interpolate with something that was not a SQL. But if everything is all right, then the source parts, they start empty. I want to push this, but I don't want to push this $sign at the end, because the $sign is just something that I have already interpreted, really. It was just there to mean that I want to do this special magic trick. So I get the $sign out by saying slice, starting with the first position and ending at -1. I'm slicing just this portion and getting rid of the last character. I will also push the parameter source. So this parameter source is something that looks like this. It will go into the source parts. So now at this point, the source parts read like this without the $sign and the source of the query that I'm interpolating. And the parameters I just pushed to my parameters. So if I am building a bigger query, at this point, everything that was an interpolation here, so maybe I'll have something that reads like name equals question mark, then I have some interpolations here that I need to happen, and I can just glue in the parameters that were in the inner query, which is a parameter in this case. I can just push the parameters of the parameter into my parameters. What an excellent sentence. Okay, so that's the special case with the magic trick for interpolating literal SQL. In most cases, that's not what's happening. So what I do is I take the source part. So let's come back to our example where interpolation was not happening. So it was just this. And in particular, it was just that. So our source here is this. Our parameter is this. Then what I do is I push into the source parts, that array, that buffer, the template part, which is this, and a question mark. So it produces this part of the list. And then on the parameters, I push the parameter, which is a value, like the number 30. So it produces this part. And then I do that again and again. So in this case, I will do that with this, along with that, and then this, along with that. But we are still missing the last one, which has no corresponding parameter. Well, what I do with the last one is just I push it to the source parts. So I have the source parts which is my buffer into which I'm building the query. I push the last one, which is length -1. So I'm pushing the last part of the template into the source parts. I join everything together, and I'm off to the races. That's the implementation of the tag template literal. Now let's briefly go over the tests. What I'm doing to test is I am just calling my tag template. I'm testing two things. I'm testing the SQL and I'm testing the database class. To test the SQL, I am doing a bunch of tests with no interpolation, with a simple interpolation, with raw interpolation, which is the double or sign trick. And in every case, I am just using the toMatch inline snapshot. So to actually implement this, I did not write any of this. I think this is one of the best features from, what's the name of the library? Jest. The name of the library is Jest. So there is this library called Jest for testing, and that's what I'm using. That's probably the most popular testing library these days. So I just wrote this, and then I ran the tests, and the tests should pass. And then Jest is going to look at the output of this and put it here. So I look at it and I say, is this what I expected to see? Oh, yes, it is. Okay. So I write the tests super fast because I just have to write the test cases and I can inspect the output and see if it matches my expectations. And then, of course, now that this is in place, if you change something about the implementation in a way that breaks this, then the test will not just update this, it will break. So if I run the test again, it will not try to replace this, it will check against this and fail the test because I changed the input. So for the database, I create a database and I execute a query to create a table, and I run some queries against that table using run and then get and then all and then iterate. And one thing you may notice about these tests is that I'm repeating myself a lot. That's on purpose. It's possible to first reuse the database because I could just create a table in the database and reuse it in all my tests, or I could have something like a function that is called before every test. There is a facility in Jest to call a function before every test or before all tests. I think it's more explicit and better to have tests that read with no magic. So that's why I'm repeating myself. It's more verbose, but in this case there is so little setup that I don't think it's beneficial to extract or try to abstract this in any way. And then in most cases, I'm just, again, calling the function that I want to test with match inline snapshot. I think that's the only technique I use in this whole suite of tests. Yeah, as you can see, all the expects are just match inline snapshot. So I'm just calling the things as I would here in the terminal to show you how things are working. I'm just calling those methods with expect and to match inline snapshot. And that's the story about testing. In the TypeScript configuration, I do have a folder for source and lib because I want to distribute the compiled files in JavaScript. So if you don't have TypeScript installed, you don't have to worry about that. So I do have a root dir and an out dir. I'm targeting this version of ECMAScript because I think it's the one that is supported by most recent and still used Node.js versions. And I'm still targeting CommonJS because ES modules are a new thing, but they are not here yet. Many packages don't work well. In particular, Jest, I think still has experimental support for ECMAScript modules directly in Node. So it makes more sense to use CommonJS these days. And that's why I have this line as well, so that I can interoperate with libraries that are still using CommonJS. And then I'm outputting source maps and declaration files. These are these files that are used in Visual Studio Code to help with autocompletion and also in TypeScript. And then I want to do all the validations you can in TypeScript. So strict mode will give me more warnings and errors. Then what I have over here is super simple, the stuff that you have to just metadata about the package. This line I think is interesting. If you have a package that is scoped with your name, then by default it will be private, so these lines make it public. Then my script is called prettier for formatting and jest for testing, and the prepare script is called anytime you install the package, so you can install this package from GitHub if you want. You don't have to go through npm if you don't want. You can call this from GitHub and it will run TypeScript and it will compile to JavaScript. You can also, and what I mean by installing from GitHub is in any kind of project. So if you have a project over here, you can install at liafac SQLite. This will get this from npm, but you can also do it like this, which is sort of magic, but the thing is, my repository on GitHub reads like this. So if you do it like that, then this will install from GitHub and it will compile the TypeScript for you because there is the prepare script here. The prepare script is also used before publishing. So we'll see how the package is published right here. But when we run npm publish, it will run prepare and produce the JavaScript. For dependencies, I'm depending, and this is interesting, I'm depending on better SQLite 3, that's true, but I'm also depending on types better SQLite 3. And this is interesting because usually the types go into the dev dependencies, but in this case I have a library that I want other people to consume, and this library, and it may be consumed in TypeScript, but this library is exporting a class that depends on better SQLite 3. So if I don't have this line here on the dependencies, the types for better SQLite 3 will not be installed along with my library. And in the end of the day, you will get a type error because TypeScript cannot analyze this part to get all the methods that come from better SQLite 3. So methods that are like the exec method, the prepare method, and so on. All these methods we look at. So I need to have the types as a dependency, a production dependency, which is unusual. In most apps, you would never do this. In some libraries, it depends. If you are using the types only internally, that's fine, but if you're exporting something that depends on an external type, you have to put that as a production dependency. For the devs types, there is nothing too surprising here. I have the types for the things I'm using. I have jest, I have prettier, so that's formatting, that's testing. I have this to bridge the gap between jest and TypeScript. I have this so that I can do things like what I did before and just interact with the library here on the console. TypeScript. The configuration for jest is only look at the tests in the source folder, otherwise it would look at the tests in lib as well. Not what I want, that would run the tests twice. Installing TS jest and running the test environment as Node because by default it would run as if it was in the browser with the browser APIs, not the intent. Finally, let's look at the GitHub Actions for this package. This is going to run on every push, it's going to run the tests, and it's going to publish to npm. I'm running the tests on different operating systems and on different versions of Node, and Node 16 has come out yesterday, so I'm going to run on 16 as well. And the steps are just check out the repository, set up the node with the node version that I'm testing against, and run this nifty npm command that installs the library, the dependencies in CI mode, so it will look at the package log file and it will respect whatever is there. It will not try to update any version or do any resolution. It will look at the resolution that has already been made and that is already logged into the package log file. And then right after that, it will run the tests. So if all the tests are passing and I'm pushing a tag, so if I have a tag is something I can create with something like npm version minor, that will create a tag in the Git repository. So if I am running a tag and the tests have passed, then I can do this in whatever operating system. I'm doing this in Ubuntu. I'm going to check out, use the latest Node version with this registry. I have already set up this secret, so I am able to publish to the repository. So the secret is over here in settings on GitHub. And then there is this secrets page in which I set the npm token that I got from npm.org. I just npm.js.org. I went there, got the API key, and configured it in GitHub. And then I can just use this environment variable to set that token and publish to the directory, to npm directly. And what I do here is install the dependencies, because remember, I will have to run TypeScript to compile my JavaScript. So I run CI and then I publish, and that is it. That is the end of our tour, because at this point we looked at the implementation of the library, the tests, the TypeScript configuration, the project configuration, the GitHub Actions configuration, and that's this story. I really like using SQLite in most of my projects. I think that using tagged template literals and not having to manage objects like the statement objects all over the place is the most convenient way of writing queries for SQLite. I hope you liked this package, and I hope you liked this code review. If you did, make sure you subscribe to the channel, because I always have more of these things coming out about Node.js, about Reaper, about video production, about web development, all these sorts of things. You can also support me on Patreon and PayPal. The support from those people is what keeps me motivated to do these videos. Thank you very much for watching. I see you on the next one. Bye.